Hello and welcome to another daily challenge. Let's begin our question. Okay, let's see. Question 875. Koko eating bananas. Medium level question. Koko loves eating bananas. There are n piles of bananas. The ith pile has piles I bananas. The guards have gone and will come back. The guards have left and will come back in H hours. Koko can decide her bananas per hour eating. Oh, Koko can decide her bananas per hour eating speed of K. So it's probably a rate. Each hour, she chooses some pile of bananas. Each hour. Oh, right. Okay. So each hour she chooses some pile of bananas and eats K bananas from that pile. If the pile has less than K bananas, she eats all of them instead and will not. Wait, if the pile has less than K bananas, she eats all of them instead and will not eat. She will eat all of them instead and will not eat any more bananas during this hour. Oh, if the pile has less than K bananas, she will eat all of them instead and will not eat any more bananas. Koko likes to eat slowly, but still wants to finish all of her bananas before the guards return. Return the minimum integer K such that she can eat all the bananas within H hours. Okay, so it sounds like we got some pile of bananas. We got some piles of bananas. And in each pile, there's some number of bananas. A monkey, whose name is Koko, can just at some rate can eat bananas with the one condition that when she starts eating from one pile, she will not switch to any other pile within that hour. So let's say that a pile has 5 bananas and her um, eating rate is 2 bananas per hour. It's a very slow monkey, but it would take her 3 hours to finish that pile because after the first hour, she will have 3 bananas left. After the second hour, she will have 1 banana left. And after the and during the third hour, she will only eat 1 banana, not moving 30 minutes into eating her 1 banana to another pile. So let's see if we are correct about that. Uh, Piles 3, 6, 7, 11, and the guards are gone for 8 hours. So, okay, how do we do this? Guards are gone for 8 hours. So if we, yeah, well, first of all, the rate here is 4 bananas per hour. So, 4 bananas per hour, that means that it would take her 3 hours to finish this. That's three. It would take her 2 hours to finish this. That's five. It would take her 2 hours to finish this. That's seven. And 1 hour to finish that. That's eight. Okay. Um, I know the answer because this is a very similar question to one that we did yesterday, and Leetcode tends to um, repeat question types from day to day. So, but however, how will I visualize this in a graphic? Um, let's try to do something similar to what I did yesterday. We have 3, 6, and 7. For the sake of drawing this, I'm not going to include the 11. and we have a rate. Let's see, 3 bananas per hour. Let's say that the rate is 2. Banana eating rate is 2. That means that we eat 1 and eat 2. Then we stop. Then we eat 1 more. We don't do anything here. And we stop. So actually, what I'm actually doing here is I am doing this, right? This graphic here, or this separation here, is my 2 bananas per hour eating rate. So look at how this goes. We go 1 takes 2 hours to finish the first pile. It will take 1. Let's choose 3. No, let's choose 2. And see that it would require me too much drawing to do. And then essentially just copy this. So that's going to be my 6, and this is going to be my 7 instead of here. Pretty quickly, you should see that it would take me 1, 2, 3, 4, 5, 6, 7, 8, 9. It would take me 9 hours to finish at a rate of 2. And well, I don't know if this is apparent to you, but this immediately just strikes 3 divided by 2, which is 1, and with some remainder. So if 3 modulo 2 is equal to 0, then we get a situation where there's an even divide. If 3 modulo, if some number modulo 2 it has a remainder, then we essentially see that number doesn't divide evenly, which means that some of the hour that the Koko is eating bananas will be wasted on not eating bananas. So that we have this outline, let's first of all make this a little bit more. Let's see, 3, then we have 5, then we have 4. I'm just going to leave this drawing here for now because I'm now going to talk about the approach. The approach here is the following. We can define a function that tells me, given the piles of bananas and given the rate at which Koko is eating those bananas, give me the time it would take for me to eat those bananas. That statement doesn't make sense, then what I just displayed here should explain that we can actually know the amount of time it would take me to eat all of the bananas given the piles, this array, and the banana eating rate. So let me first define that quickly. Hours to eat given rate. How do I do this? So let's see. Hours 0 for pile in piles. For pile in piles, I'm going to say that hours plus equals um, hours plus equals pile divided by rate. So pile divided by uh, bananas. Some pile is just basically bananas divided by the bananas per hour gives me hours. And then if pile modulo 2 it does not equal 0, meaning that we're looking at something like this, then we simply say hours plus equals 1 and return hours. This right here is just our function. So now I'm going to delete the function. This should make sense at this point. And let's continue on. What is the second part of this problem? Second part of this problem is we should understand that one approach that I'm going to display right now is iteratively starting at hours 0 and saying while hours is less than h. No. Sorry. Hours. Oh, we also need rate. Let's say start at 1. Rate at 1. If hours. No, sorry, rate. Oh, we had this. No, we had the clock last time. If hours is less than h, then I'm going to say, sorry, if hours is bigger, then I'm going to say break, return, and this is going to be rate plus equals 1, and I'm going to return rate minus 1. And nothing works. Output 0 if hours while hours is less than h, hours is equal to this, and we don't even need break. Hours. Okay, let's say rate is equal to 1. Let's increment rate here and say this. Hours is equal to rate. Rate 1 banana. Okay, so I'm already doing something wrong. Let's think through this quickly by looking at the response. We have piles 3, 6, 7, 11, and we have h equaling 8. At rate 1, use all the variables correctly. I don't like that. This work? No. Okay. The logic here. I set the hours to eat the bananas as 0. And while hours to eat bananas is less than the hours of the hours while the guards are gone, I'm saying that I'm going to increase my rate to be 1 and see. Oh, sorry. At rate 1, it's going to take too many hours for the monkey to finish eating the bananas. So I was looking at this wrong. Um, um, it's just 9 million. Uh, 999. Big number. Bum. So at hours, while hours of eating the bananas is bigger than hours um, that the guards are gone, because that's where we're starting from. We're starting at rate equaling 0, which means basically an infinity time to finish the bananas. Actually, I can just do this. There we go. At rate 0, at rate 1, we're going to count how many hours it takes to eat all of the bananas. It's definitely going to be more than h, than the number of hours that the guards are gone. And while hours to eat the bananas is bigger than h, we're continuing to increase the rate, which actually decreases the number of hours to eat the bananas, which should eventually put us over the limit of hours to eat the bananas. So at some point, we are a little bit lower. It takes us one lower time, 1 hour less to eat the bananas, or even the or the exact amount of time to eat the bananas while the guards are gone, which pushes our rate up to the exact banana eating rate. And so this should work, except should probably hit run first. This will work, except that we're going to hit a time limit exceeded, because if the expected 4 minus 1. Jesus Christ, what am I doing something wrong? Print hours to eat bananas. I have the rate. Let's just manually test this. What would it take for me to eat 4? This should print 7. So this is wrong. My hours to eat the bananas is wrong. No wonder. Where was I? Turn 0, 7. So where am I going wrong with this? For pile and piles, hours is going to be pile divided by rate. If pile divided by 2, it should be rate. There we go. I don't know why I said 2. I said 2 because in the example I had 2, and I guess I'm still not restarting the video, so let's see, output 4, and whew, okay, fine, we're all good now. The logic here is correct. As the rate is increasing, it is decreasing the amount of time it takes us to eat the bananas. As soon as we hit that limit, or past that threshold of hours to eat the bananas being slightly less or equal to the number of hours that the guards are gone, we return the rate. However, when I submit this, we should hit a time limit exceeded. Why? Because we are incrementally starting from the lowest possible rate and going up until output 0. Okay. If you don't like this, I'll start like this. But this is going to throw me an error. Yeah, you cannot divide by 0. Fine. I'm just gonna there's probably some weird condition. No, I should do it correctly. This was correct, except for one case where I returned, what did I return? 0. Um, I'll just do it again and I'll keep talking. That the issue that I should be hitting a time limit exceeded is because I'm starting from 1 and going all the way to the result the big result. However, a faster way to do this is to do a binary search over answers. Binary search over answers would work something like this. We first define a low and a high rate, the lowest possible being what is the lowest rate that you can eat any bananas? Well, 1. And what is the max rate that you can eat any bananas? That would make sense. Well, the fastest rate I could eat any bananas is actually the max of the pile because I cannot eat faster than the biggest pile, right? Even if I was to eat one greater than the biggest pile, it would still take me the number of piles hours to eat all of the bananas. So let's say here, let's see what is the uh is this just a weird condition? If len of piles is equal to 1 and mm, and piles 0 divided by h is 3, 3, 3, 3, 3, 3, is equal to 0, then return 1. Let's quickly copy this. Use test case. See that this passes. And finally, we should hit that time limit exceeded error. Anyway, while I'm doing this, I'm actually going to start modifying this code right here because I'm taking way too long. Time limit exceeded, finally. So on inputs that are ginormous, it will take me n squared times to finish this search. However, I could be doing it in n log n. Here's how to do it. Min rate is going to be 1, as we decided. Max rate is going to be the max of the piles. And pretty simple here, very similar to the previous question. While min rate is smaller than max rate, we're first going to find a mid rate, where it's going to be min rate plus max rate divided by 2, and then if, now this is the crucial part, if hours to eat given a rate, and we do mid rate. If hours to eat is greater than the is greater than h, so something that doesn't satisfy our answer, then we have to increase the rate. Min rate then becomes plus mid rate. So let me just quickly explain this. If the number of hours it takes us to eat all of the bananas is greater than the required h, then we need to increase our eating rate. We need to increase min rate to mid, cutting all of our options down in half on the initial, plus one. The one here is because the plus one is because, first of all, our answer already doesn't satisfy it. And in division, we're always rounding down. Else, if we are eating our bananas too fast, we want to slow down our rate because Koko doesn't like eating fast. So we say that the max is now is actually just mid rate. And finally, we return min rate. Let's see if this works. Accepted. Runs in significantly faster and beats 75% of the responses. So, yeah, let me clean this up a bit so you guys can see. But and let's see what are the faster solutions here. There seems like there's a lot. My guess is that somehow they are choosing the min and the max faster, while L. So let's see. LR, how long? Same thing here, binary search. How long and piles mid. So so they're passing down the files, and so my one, yeah, what they're probably, so there's two differences here that's making this faster, although it's not significantly faster. One is they're using a ceiling function, which is rounding. I know what they're doing here. This might be a good addition to our code. But another thing that they're doing here, I feel like, is why are they? So once you find the time, if time is less than or equal to h, then they're first finding the min between the mid and then setting the right bound to mid minus 2. Okay, I don't get this. It doesn't really seem intuitive. Here, minimum is max, left, right. Okay, so they're utilizing another variable called minimum to divide their solution into a smaller amount. So maybe it's log base 3 of n or something. I don't really care about that. Let's just use the one thing that I saw them how they made this better. They made ceiling of x divided by 2 should work. Let's see if this increases our solution time, but I really doubt. Oh, so, okay, so, yeah, this is clearly the killer here. Maybe they're not even using some clever way to reduce it to log base of 3. I would just use this. This beats 96%, and it's just simple ceiling function. I'm sure all of you will know. So cool. Thanks for watching, and I'll catch you in the next one. Bye.